Hi everyone, and I thank you for joining me today. My name is Kevin Beals, and I'm with TI Marketing Group. My specific title is Channel Marketing Engineer, and I'm here today to talk about a few new innovative power ICs that we have. Just a little bit of an agenda, and I have it on the abstract also. The TPS 55010 I'm going to chat a little bit about first. It's an isolated DC-DC converter. Then I'm going to go into the integrated power solutions, the power block from our FET portfolio, a high current step-down converter. That's our TPS 56221, a very interesting part. And then I'm going to wrap it up with the power management IC and the TPS 65910. Alright, talking first about the TPS 55010. It's an isolated DC-DC converter like I told you. I'm going to get into a little bit of just a one-slide overview here, and I'm going to go a little bit deeper in the next couple slides. This isn't really intended to be a deep technical presentation, more of an overview. If you do have more questions about the technical details of one of the parts I'm going to talk about, then feel free to email me. I had it on the first slide, and I'll have my email on the last slide again. Alright, the first part is the TPS 55010. It's a 2.95 to 6 volt in, 2 watt isolated DC-DC converter with integrated FETs. This flyblock topology that we have created this part with is also known as an asymmetrical half bridge, for those of you who are interested in topologies, but it operates like a synchronous buck. The goal of this is to have a low part count isolated DC-DC converter. It's a 45 milliohm half bridge, primary side feedback, and so no optocoupler is going to be required for you there. We're able to get 85% efficiency at 5 volts, 200 milliamps, and it's a programmable side voltage with a resistor divider. It synchronizes to an external clock, and that eliminates beat noise, and has an adjustable slow start that will limit your inrush current. I'm going to go into a little bit more applications in a minute, but on the lower right hand side you see a typical schematic there that you can kind of glean from. Like I said, it's an isolated regulator, and here on the right I just really wanted to show this for the idea of what kind of efficiency and load regulation you're going to be looking at here. Across the output current from 2 milliamps to 220 milliamps at 5 volt, you're looking pretty darn close to 5 volts. Very good regulation with this isolated regulator here. Also, one very key fact is look at the efficiency there. We're in the mid-80s, it looks like, as a 5 volt efficiency, or 5 volt output when your input's 5 volt, but you have isolation there. Your magnetics, your isolation is actually it's a selectable based on what magnetics you choose. We have a couple recommended there. The Worth 750, 311, 880, and 780 to provide 2 kV of isolation and 2.5 kV of isolation. These are just some of the applications that we have, and this is where I'm kind of going to pose a question to you guys. Here's where we've found that this part can play very well: medical, aircraft, floating supplies for IGBT gate drivers, and the like. But we really don't know all the positions this can fit in. So if you think you have an application for this and want more information, feel free to shoot me an email. But if you think you may know where this fits in your application, go ahead and shoot me an email and just let me know what kind of system that you're going to be looking at, and so that way I can add it to this list. And who would use these? Well, generally people who would need these need a simple, flexible, isolated supply for industrial control applications. That's really the main purpose of this. Is if you have a 5 volt rail or 3.3 volt rail available and you need it isolated, this is kind of the part that we would recommend for that. It's like I said, it's not really matched in the industry right now, but we are interested in finding out what more applications that can be used for. The second part I wanted to talk about today was the TPS 84620. Alright, we released this part a few months ago, and it's the first of a family called the Integrated Power Solution family. What really makes this family unique is its ability to integrate many of TI's specialties into one package, so that way you can get a solution fast, easy, and reliable. So what is the 84620? Why are we calling it an integrated power solution? Well, it's not a module. It still does require a few external components, an input cap, an output cap, and a set resistor at minimum. But it does include the inductor and some of the smaller passive resistors already are packaged inside of one solution for you. So basically what you have is not quite a module, because modules have all your components, but about as close as you can get. You just need, like I said, a set resistor and a couple of caps. It's an easy mount 15 by 9 package, and these packages, what we've done that our competitors haven't done is make them thermally very thermally efficient. So as you can see, 95% peak efficiency and 13 degrees C per watt. 13 degrees C per watt, theta JA is what I was referring to, and whenever I was talking about thermally. 800 watts per cubic inch, well, I think it's supposed to be square inch, is relative to the size. But we did come out with this. We did come out with a suite of features that this has. It's adjustable frequency, soft start, UVLO with track, clock, and PG pins, programmable pins. So just want to let you know there are as few as 3 external components required. When we're looking at our competitors, this is roughly 40% smaller package. A lot of them are 15 by 15 packages, and we're 15 by 9, so you're able to get that 6 amps that we was talking about, the 6 amps, which is the output current maximum for this part. You're able to get that same output current in 40% smaller area. This has a lot of flexibility in this part, and I'm going to go through some of the applications here in a sec. But this part is released, it's orderable, and EVM is available for order. So here's an example of our thermal performance. I said this is one point where we really step away from the competition. It provides 6 amps continuous current at up to 85 degrees C ambient with no airflow, and that's optimized for 12 volt and 5 volt inputs. We kind of have a thermal image there on the lower right hand corner. You can see that entire, well, the yellow part is our package. It's 15 by 9, and the 2 hotspots on there are going to be the IC junction temperature of the FETs and the inductor, which the top one I believe is the inductor and the bottom one is junction temperature of the FETs. As you can see, it's fairly evenly matched, 58.9 for the inductor and 58.8 for the FETs. That's that 13 degrees C per watt junction to ambient temperature I was talking about. 58.9 degrees C, and that's with 12 volts in, 3.3 volts out at our full 6 amps. And it's a 30 degrees C rise at full load. So some of you may be saying, why would I go with this instead of just designing discretely? And we came up with one kind of slide to show you that, why you would use this, what kind of people would use this. Well, this a discrete solution, and we're a big proponent of those. We make many of the ICs that fit in that also. A discrete solution requires a lot of loop compensation and layout expertise. A lot of designers who work with power have been doing it for many years because of these 2 main topics here. Well, with ours, it significantly less design effort goes into it. It also achieves a smaller size with fewer components. So at an overall size that we did, we had our power supply experts design the smallest 6 amp DC-DC converter that they could and create an entire power solution, and it still ended up almost equal in size to the TPS 84620. So you can't really get a whole lot smaller than this, but this does significantly reduce your design effort. Another really good advantage of this is a novice can achieve the performance of an expert. I mean, with someone who has very little power supply design experience, you can read through our data sheet and app notes and basically design a expert level power system with very little previous knowledge. So overall, this is similar to a plug-in power module, but at a very good price point, and also a little bit more flexibility in your design. I did want to mention a little bit of a competition. I couldn't put their names up there, but here's kind of where we stack up and how we marry up to everyone else. As you can see, the key things that I was talking about are the thermal resistance, which is ours is 13 degrees C per watt, matched only by competitor B. Everyone else is significantly worse. But also look at the package size there. We're 9 by 15, and a lot of our other competitors are 15 by 15, and even taller than that at 3.5 or 4.5 millimeters. But something that really also is a key benefit to using our TPS 84620 is the feature that you get. You basically get all these features built in there for free, already designed in, and you're just able to use them and take advantage of their properties. So who is right for this part? We have a bunch of key applications, but really it's the list is infinite here. I mean, it's anyone who needs a 6 amp rail who can who has 4.5 to 14.5 volts in. So 5 volt bus or 12 volt bus, and you need 3.3 out or 1.2 out. We're able to do that cost effectively and in a size and thermal efficiency and simply and fastly. Quick to market time is what we've really tried to promote with this part. Also, if you have limited PCB area, this is a very benefit to you because you're able to get the size of an expert power supply designer without having an expert power supply designer on hand. You can still get that small space. Next, I wanted to talk about our power block. I'm going to talk about the CSD 86350 and 87350. They're very similar parts, just a different upper end voltage. But this is part of our NexFET family. A few years ago, TI has acquired a company called Synchronous, and now we have expanded their portfolio and come out with power blocks, which basically join your high side and low side FET into one package. And we're able to do some really special things with it. So what the CSD 86350 is a synchronous buck NexFET power block half bridge. So basically we've combined your high side and low side FET into one thermally efficient and small package that allows you to not only save space but improve efficiency. So something that these dual NexFETs, one of the key benefits about them is you're able to drop in this power block into your current system and see an immediate efficiency gain, which is rather astounding. Whenever you're talking about simply by changing the FETs, you're able to see 1 or 2% or 3% efficiency gain with a simple FET change. It can really drastically improve your efficiency. We boast this one at 90% at 25 amps and 93% peak for the CSD 86350. And we do that with a single 5x6 outline using half the PCB area versus a discrete solution. Typical applications for this are PCs, servers, point-of-load DC-DC, that sort of stuff. The CSD 87350 is part of our 30 volt FET line. The 86350 is part of our 25 volt FET line. This is part of our 30 volt FET line. So that's really the main difference between these. It's still 30 volt breakdown voltage. It's still 90% of 25 amps and then 93% peak. And most of the other specs are relatively similar. Really, the target applications here, we've noticed that now people are needing more and more higher currents in their system, at the same time needing that high level of efficiency that they can get easier with lower currents. This is where this fits really well, is in high current applications that need high efficiencies. Typically, processor power, all that good stuff is where a lot of these parts play. The NexFET power block really fits inside solutions where space is a constraint and efficiency is a extreme care about. Just kind of wanted to prove to you guys what I was saying. I know I'm saying, oh yeah, 2% efficiency gain. We took two of our FETs with similar on resistances to our power block, and we ran them in the same exact system. So this is a 12 volt to 5 volt, or no, sorry, a 12 volt to 1.3 volt with a 5 volt VGS, and then switching at 500 kilohertz with a 0.3 microhenry inductor, and the junction temperature, or the ambient temperature, was 25 degrees C. So the efficiency here, as you can see, is significantly higher over the load range. Up to 25 amps, you're looking at the power block, which is red, being over 90% efficient, 90.5% roughly, whereas just the other FETs, and these are still our NexFETs, which are industry leading as far as efficiency goes, hanging right around 88% efficient. Now, if you compare the power block to some of our competitors' FETs, you may see that 2% grow into 3, 4, 5% efficiency gains simply by changing the FETs. And I also wanted to tell you the max current rating on these is 40 amps, and we do have data to show that. Here is the data over, again, 12 to 1.3 over the load range. So it peaks at 93, just over 93% efficient, and then at 40 amps, it is still over 86% efficient. And that's still in the single 5x6 package. We do have these in a 3x3 package also that are good for lower current limits, and if you're interested in those, I ask you to just go to ti.com and type in CSD8, and that'll bring you to the entire package of our power blocks. Now, if you're interested in the single individual FETs that we have, you would just type in CSD1, and that will bring you to all of our individual FETs. This part's one of my favorites and one of the newest and neatest power parts that we've released. It's called the TPS 56221, and it is a high current step-down converter. Now, with this part, we're going to integrate two of TI's strengths and technology to make one really great part for you. So what is this TPS 56221? It's a 4.5 to 14 volt input, 25 amp step down Swift converter. So what we were able to do is use our NexFET technology with our DC-DC controller technology to create a one small package that's able to be a DC-DC converter for up to 25 amps. Okay, we also have a 15 amp version of this that I'm not going to talk about. That's the TPS 56121. What makes this part so great? Besides the fact that it can do 25 amps, it can do it efficiently. It's 90% efficient at full load at 25 amps, and it's still in that 5x6 QFN package. We found it was about 5% more efficient than similar 25 amp solutions on the market, and about 30% less power dissipation than 25 amp converters. Additionally, it's 30% smaller than designing a 25 amp discrete solution, and delivers 200 watts per cubic inch with an easy layout solution. In the lower right hand corner is a basic schematic of the solution. Again, this has many applications. Point of load and network and telecom that requires high current, non-isolated DC-DC power modules, data storage, and industrial test. I wanted to show you guys definitely a slide of performance, because it's kind of thinking, okay, well, it's 90% efficient at 25 amps. Is it significantly worse than that at lower loads? And the answer is no. We're over 90% from 5 amps on. And the right thermal graph shows you how cool we can stay with that. From 12 to 1.2 at 500 kilohertz, 25 amps full load, that we reached a temperature of 88.1 degrees C. Comparing this to some of our competitors that we were able to find, some of these were combining two solutions from competitors, but this is efficiency-wise what we could find for competition in the market right now, and as you can see, we're head and shoulders above anyone else we could find for having an integrated solution like ours. Finally, I wanted to talk about the TPS65910X. What this family is it's power management ICs for ARM processors. If you're not quite sure what a power management IC is, it's basically a combination of multiple power rails, or one part that's able to do multiple power output rails. And we have a family of them called the TPS 65910X that are new, and they're designed more specifically for ARM processors. Here's kind of just the big block diagram of what is inside one of these. 3 step-down converters, DC-DC converters, 8 LDO converters, so there's 11 voltages there, a backup battery charger, a 5-volt boost. If you need an RTC, clock manager, I2C, everything like that, it plays well. Just the one slide quick overview that I wanted to talk about. We have 2 step-down converters with smart reflex capability. Those are for the core supplies. Those are 1.5 amps max. The third step-down converter is a 1.8 volt or 3.3 volt step down for I/O, and that's a 1 amp max. Typically with ARM processors, you have many peripherals and processor power rails, so we made 8 configurable low noise LDOs for these. To prove that we have fast time to market, we have many reference designs for several OMAP, Satara, and Samsung processors, and we're working on more in the house every day. What makes this ideal for portable applications is the integration. It's 50% smaller than you could get by doing this discretely. We did that we did all this, the 2 step-down converters, or 3 really step-down converters, a boost, 5-volt, 100 milliamp converter, and 8 low-noise LDOs, all in a 6x6 millimeter package. That's really some of the differentiation on this. It's easy, it's factory programmable EEPROM, and it's competitive pricing if you have a cost-sensitive application. Just letting you know that we weren't just making stuff up here. I kind of put the suite of the TPS 65910X targeted processors. So of course we have all of our TI processors immediately right out front, the AM35s, the AM37s, the DM37s, the OMAP 3s. All those are completely supported and have collateral supporting them that we can get for you. Then we're looking at Samsung and Freescale. We have reference designs for. So that's it's not just dedicated for TI ARM processors. We're willing to play with everyone. And I just kind of wanted to let you know, it's not this specific part. It's not the only one we have that works for specific processors. I did want to show you the entire suite of embedded processors that we have power management units for. Power management unit is just another word for power management IC. I mean, these are sort of the table that we have that you could look up. Any processor that you want that's on this list, we have the corresponding PMU that you would use in TI's system. We have, everything from, of course, all of our TIs on the left, and then on the right we have Freescale, Marvell, and then NVIDIA, Samsung, and more. So if you're interested and you have already chosen a processor that's on the right-hand side, feel free to look at those. If not, I would suggest you view some of the processor presentations also. Alright, that's all I have for you guys. Again, my name is Kevin Beals, and my email is in the lower left-hand corner there, kevin.beals@ti.com. Please send me an email, let me know comments, suggestions. If you have new ideas or anything that uses one of these parts, I'm more than willing to help. I can get you in touch with the right people. Other than that, thank you guys very much, and I appreciate your time. Bye.